All right, welcome back, everybody. Today we're going to be going through and talking about how we solve logarithmic equations. So coming over here looking at our first problem, this is your homework help video, of course. The main idea here is that you want to rewrite as an exponential. So remember, anytime you see a log without a base, it's base 10. So if I just rewrite this as an exponential, I would have 10 to the first is equal to 4x. Now, once you get to this spot, 10 to the first is just 10 is equal to 4x. So to solve this, divide by 4, divide by 4. X, 10 to the negative 1. I'm sorry, guys. 10 to the negative 1 is not just 10. So let's go back here for a second. So what we do, 10 to the negative 1 would be 1 over 10 would be equal to 4x. Dividing by 4 on both sides would make this into 1 over 40 is equal to just x. So that's what x is in this problem. Of course, you can actually punch that in on your calculator as well to check. That's the beauty in a lot of these problems. With this one, since it is just base 10, we can use our normal log button. So 4 times 1 over 40 gives us that answer of negative 1 that we were looking for. Moving ahead to problem number 4. Let me just pull this over to the side. We'll keep our calculator handy today. First thing we want to do is I would like to actually get rid of the 6 here. So I'm going to divide off the 6 since it's hooked on by multiplication. So dividing both sides by 6, I get log. This is going to be base 10 of 4x is equal to 2. So that means 10 to the second power is equal to 4x when I rewrite it, right? 10 to the second power equals 4x. So coming over there, 10 to the second, that's just 100, is equal to 4x, not 4 to the x. I don't know why I wrote it like that. So solving this, I would need to divide by 4, divide by 4. X ends up being equal to 25. Again, you can punch that in. 6 log 4 times 25 is 12. So just like that, we're done. Move on to play. Looking at problem number 6. Now we got a quantity in there, so when we rewrite this, we're going to rewrite it as 4 to the third is equal to that quantity, 2x plus 4. Now 4 to the third is a number, so let's figure out that number. That's 64 is equal to 2x plus 4. So solving this, minus 4 from both sides, I get 60 is equal to 2x. Dividing by 2, I find out that x ends up being equal to 30, and we're done. Looking ahead to problem number 8 right here. Again, we have that 2 in front, so we're going to get rid of that right away by dividing by it. Divide by 2, divide by 2. I'm going to have log base 3 of 2x plus 5 is equal to just 2. So rewriting that, 3 to the second is equal to 2x plus 5. 3 to the second is, of course, just 9. So I get 2x plus 5 is equal to 9. Subtracting 5 from both sides, I get 4 is equal to 2x, which means x equals 2. So to check that, that one's a little bit harder to check, but we certainly can do it. Here's how I would recommend it. I would type in a 2 times, then you have to use your math key, and you can go down and find the one that says log base. Every calculator enters this in differently. If yours is nice and has a little box there, that will be pretty easy there. If you have questions about how to enter this, please don't hesitate to let me know. 2 times 2 plus 5. Okay, look at, we get 4. We know we did the problem right. Moving on to problem number 10. Here we see we have 2 logarithms, so our first job is to put those together to condense them. So I'm going to have log base 2. Remember, subtraction means division, is equal to 4. So rewriting this, I'm going to have 2 to the 4th power is equal to 2x over 3. 2 to the 4th power is just 16, is equal to 2x over 3. Multiplying both sides by 3, I get 48 is equal to 2x, which means x is just equal to 24. And we are done. So that is problem number 10. Again, you could plug that in and check it just the same. Looking at problem number 12 here, again, I see 2 logs on the side, so I'm going to need to combine those into 1. We are subtracting here, so that means we're going to have log base 5 of x plus 12 over x is equal to log base 5 of 7. Cool thing about this problem, they both are log base 5. The only way that they could actually remain equal is if this part equals this part. So we're going to set up our own separate equation where that is true. So x plus 12 over x equals 7. If I wanted to solve this, I would start by multiplying both sides by x. That will make these two go away. I'll be left with x plus 12 is equal to 7x. Now, as I come over there wanting to solve that, get your x's on the same side. I'm going to have 12 is equal to 6x. Dividing by 6, I find out x has to equal 2. And just like that, we are done. Looking at problem number 14, again, lots going on here. Here's how I would suggest it. So this 2 sitting in front is the exponent of this one. So we're going to put it back up there because these two need to get combined. Since we are subtracting, we will divide. So this will be the log. Well, officially it's base 10 of 3x to the second power. Now that second's going to each of those over 9. And that's equal to 1. So rewriting this, 10 to the first power is equal to 3x to the second squared over 9. 10 to the first is just 10. 3x squared is going to be 9x squared over 9. Of course, these two 9s do cancel each other out. So I'm just left with 10 is equal to x squared. So to get x alone, you would square root both sides. This, of course, introduces a plus or minus on the side with just the number. That cancels these, leaving you with just x. So I'm left with plus or minus the square root of 10. So that's two different answers, positive square root of 10 and negative square root of 10. Now, fortunately for us, we know we can never have that negative one, so that one goes away, making this our answer. Moving on to problem number 16 here. Again, this 2 is an exponent, so that's going to go up on top when we combine these. So this will be log base 10, since we don't see anything, of x to the second over 4 is equal to 2. So rewriting this thing, I'm going to have 10 to the second is equal to x squared over 4. 10 to the second is just 100. X squared over 4. Multiplying both sides by 4, I get x squared is equal to 400. And then coming over there and square rooting both sides, I'm going to get x is equal to plus or minus, square root of 400 is just 20. But we do know we can't have the negative 1, so that means x equals 20. It doesn't equal the negative 20. Looking at problem number 18 right now, we have two of them that are being added together. That means we multiply when we try to combine these. So I'm going to have log base 6 of x plus 5 times x, right? This is a quantity right here, is equal to 2. Now rewriting that, I'm going to get 6 to the second is equal to x plus 5 times x. 6 to the second is 36, so I get 36 is equal to x squared plus 5x. Now coming over here trying to solve this problem, it's a quadratic, so I want to set it equal to 0. So subtracting 36 from both sides, I will end up here. Now, one way to solve a quadratic is to do it by factoring. So if I tried to factor this, I would get an x plus 9 and an x minus 4. Of course, that's still set equal to 0, so that means x equals negative 9 or x equals positive 4. We can't have the negative, which means 4 is our answer. Looks like we just have two more of these left to go, so looking at problem number 20, again, we're going to start by combining. So this will be x over 4, so log, of course, base 10 of x over 4 is equal to negative 2. That means 10 to the negative 2 is equal to x over 4. 10 to the negative 2 is the same as 1 over 10 squared, which is 1 over 100, and that's equal to x over 4. To get x alone, I want to multiply both sides by 4. So I'm going to end up with 4 over 100 is equal to x, and that, of course, is just 1 over 25 equals x as our final answer. Looking over here at problem number 22, our last problem of this video, the 3 is the exponent on that x. So when I combine these together, I'm going to have log base 4 of x to the third over 1 is equal to 3. Now rewriting this thing, of course, we're going to have 4 to the third is equal to x to the third over 1. X to the third over 1 is just x to the third. So I'm at 4 to the third is equal to x to the third. Well, if these two things are equal and their exponents are the same, the only way that can happen is if 4 actually equals x. And that is our answer. X equals 4 in this problem, and we're done. Thank you guys so much for watching. Remember, it's very easy to go through and check your work on these. If you do have any questions, please do not hesitate to reach out and ask. Have a great day, everybody.